Hola, Dr. G here. This lecture is going to focus on oil, the formation of oil, the sources of oil, like where we get our oil from, crude oil naturally forming under the ground, or shale oil, or tar sands. And then when we get that oil, how do we use it to make energy? Which I think you already know the answer to that, but I'll cover it in this lecture anyway. So let's start with crude oil. A couple lectures ago, I explained to you how coal is a solid, or why coal is a solid, and it has to do with these guys. Coal comes from large terrestrial plants, and these plants have long, complex carbon chains and so many bonds to be broken. It takes so much energy to break down the solid compressed carbon to form a liquid fossil fuel, or the oil type. So oil most likely comes from smaller aquatic organisms like phytoplankton and plankton. And when these little guys just fall, and when they die, they fall to the bottom of the ocean floor, and they get mixed in with the sand. And then over millions of years, another layer of sand is deposited, and then another, and another. And then you have all this immense pressure and heat, and it compresses this into a solid and then compresses it even further to a liquid. And the reason why it moves to a liquid is because these things have very small carbon chains, very little bonds to break. And if they have very little bonds to break, that means it requires less energy to break that from a solid to a liquid. So it's easier to turn to a liquid compared to coal, because coal comes from large terrestrial plants and oil comes from most likely the smaller things, like the small, very, very, very small aquatic organisms that contain small, or that are made up of small, really short carbon chains. So again, you should be able to look at these three pictures and not know what the substance is, but know which one's a solid and which one's a liquid. Yeah, that one's a solid because of all the little bonds and all the junk attached to it. So like I taught you a couple lectures ago, this is not as energy efficient as liquid or oil because of all the energy moving into the system that needs to break the bonds so you get energy out of the system. Well, you need less energy coming into the system because you have less bonds to break. Now, that also means that pollution levels are lower. In other words, coal is more dirtier than oil because of all the things attached. And when you burn, you combust all these things, the impurities attached to the bonds. So smaller carbon chain is equal to more efficient fuel, is equal to a less polluting fuel. And we'll talk about gas in a later lecture. And this is just an image of what I was explaining, where all these little phytoplankton and plankton fall to the bottom of the ocean floor, mix in with the mud, and then you have another layer and another layer, and then all of a sudden it just gets compressed and trapped, and it becomes a liquid form of fossil fuel, because when the living organism was smaller, or when it is smaller, then it's easier to break down into a liquid. So if we look at this in terminology that you need to know with crude oil, we have a cap rock, or an impermeable layer of rock. And oftentimes you're going to have a gas deposit found with oil, because since oil can be broken down even further into a gas because of the smaller carbon chain, it might be easier for that to happen. And gas is less dense, gas is going to rise. And if it hits the bottom of the cap rock, it's going to stay here. So if you own a drilling company and you drill through the cap rock, you hire a geologist and you drill through a natural gas pocket, chances are, if you keep drilling, you're going to hit oil. Yeah, that's where the money is. Now, we have different ways that we can get oil out of the ground, or oil extraction in the first way, which, by the way, if I owned a company, I would probably do this in order. That's most likely advantageous to my pocketbook. Primary oil recovery is probably going to cost me less money. I mean, this is basically when you just drill a hole in the ground and it just naturally, the pressure gradient underground just forces the oil up. So I spend less money into the system and I get the oil out of the ground. Now, if I do an analysis and figure out that there is more oil left in the ground that will earn me money, then I might move to secondary oil recovery. And secondary oil recovery injects water into the ground. Well, we all know that oil and water don't mix. So when you shoot water into the oil well, as the level of the water starts to rise closer to the surface, it forces the oil up and up and up, and it's just easier to extract. And the third way of crude oil extraction is tertiary oil recovery, or EOR, or enhanced oil recovery. And the ultimate goal here is to reduce the viscosity of the oil. Like, you could shoot chemicals into the well that breaks down the hydrocarbons. You could shoot hot steam into the well that breaks down hydrocarbons and reduces the viscosity, making it easier for the oil to rise to the surface. Or you can insert gas or CO2 into the ground, and that increases the pressure, which then forces the oil out. Remember that from 9th grade chem? PV equals nRT? Yeah, baby. Well, it's coming into play here. So that's actually a lab that we will be doing in a couple, well, I don't know when you're watching this, or this lab is a part of the energy unit, and it's a pretty cool one as well. So this is just an example of EOR, where the company drills an additional well and shoots CO2 into the ground, and that pressure change kind of like forces the oil upwards. Or this is an example of injecting steam into the ground, which then reduces the viscosity of the oil, making it easier to rise. Now, we all know the pros of oil. It can be easily transported. It has a high net energy yield. It's cheaper. It's more efficient than coal, and it burns more completely than coal, and it's a little bit less polluting than coal. But there are cons. I mean, you have to understand that there are definitely cons, like mining oil out of the ground degrades the land. It causes erosion. Transportation, like we learned in the hydrosphere unit, could spill oil. And then finally, we have the burning of oil. Yes, it's less polluting than coal, but it still produces CO2. So the second source of oil would be shale oil. And this is highly inefficient, highly inefficient. Like, for example, we find shale rock. The shale rock is mined out of the ground. Then you take shale rock and you crush it into small little pieces. Then you take the oil shale. By the way, this formation of shale just has kerogen inside of it, which is a string of hydrocarbons that we as humans want to extract. We want to get that kerogen, the hydrocarbons, out of the shale rock. So we heat the rock to extract the kerogen. And once we heat the rock, we produce this gas, this kerogen gas, which is then condensed into a liquid, and now we have synthetic oil, which this picture tells the tale. It's highly inefficient. You might have a rock this big and produce very little synthetic oil out of this process. You got to mine it, crush it, heat it, extract the kerogen, condense the kerogen, and then voila, you have oil. Not good. I mean, you know, the process is just damaging to the environment. Now, tar sands are pretty much the same idea of extraction. Instead of kerogen, now the hydrocarbon in tar sands is bitumen. It's just a little bit different. I looked up the difference, and basically the major difference between bitumen and kerogen is the type of hydrocarbon, or the length of hydrocarbon, and this one might be a little bit higher in sulfur. But the same thing is applied. You take the tar sands out of the ground like we saw before the flood. You take the sand out of the ground, you heat it up. By heating up, you extract the bitumen, you cool the bitumen vapor and condense it, and then there you have it. You have synthetic oil. And again, this is Mordor. Remember that? They were flying in a helicopter looking down. Mordor. The guy didn't get that. He was kind of making fun of the process. Not good. All right, that's all I got for this lecture. The next lecture is going to talk about how oil is refined and then how it's used to make energy. Catch you on the flip side. Bye-bye.